Hello everyone and welcome to Crash Course of Data Science from Network Academy. I'm Akash Kulkarni, founder and CEO of Network Academy. I was getting many requests to have a simple crash course on data science, so here we are with the crash course. In this particular video, you are going to learn statistics, introduction to machine learning, types of data, that is raw and processed data as well. So make sure you watch the video till end and learn all these concepts. If you need any assistance, all the details are given in the description. If you want your friends also to see it, then make sure you share this video as much as possible because it's completely free of cost. Let's start now.
Okay, so now we begin our part one of mathematics section, that is statistics. Now see guys, when I talk about statistics, what all topic or what all areas we're gonna see, I'll just give you a basic hint. But before I move on, okay, I'll be giving you a small flow chart about how things in in statistics move. Now the very first thing that we all see or are familiar with is let's say the data. Okay, so I know that most of you must be knowing what data is, but when I talk about how you can explain the term called data, then it becomes a bit more very what will you call theoretical, or not having a proper definition would be the case with you people. So what happens is, the first thing that we see here is that in statistics portion, the very first idea is that we collect the data. Okay, the data is collected. Now in this portion, there are two ways of collecting a data. So this is what I'm giving you right now is actually a flow chart. So the very first part is collecting the data, or let's say the collection of data. Collection of data. Now for data collection also there are two areas. There are two ways. The first one is we call it as a primary source or primary data, and the second one is called as the secondary source or secondary data. Okay, now in this area we have been talking about. Now what is the difference between the primary and the secondary? First, the primary is, let's say that if I ask you to go out, okay, and find out that in your neighborhood which is the most preferable mobile brand. So you'll be going to door and you'll be asking that, okay, let's say you go to your next home and then you ask that, okay, Mr. Sharma, which phone do you use? So he'll say that, okay, I use an iPhone, and my wife uses Samsung, my son uses Vivo, and my daughter uses Oppo. So this is how you have been collecting data. So this is the data that you collected from yourself for your analysis is called as a primary data. And the second portion is secondary data. Secondary data is that data that is collected by someone else and you use it. Like suppose you people collect the data and I use it for my purpose. So this thing will be called as a secondary data. Now after the data is collected, okay, you people will be agreeing. The second process is that we organize the data. Now, why is organization important? To find a meaningful idea that, okay, where the data is going on or how to understand. Basically, you get a clear glimpse of the data understanding. Now, in this, we use certain things that is called as the frequency distribution. I'll be explaining each thing in my subsequent videos. So this is called as a frequency distribution. Most of you have heard the word called frequent. So this frequent means how often. How often. So frequency means the number of times. So there we'll be organizing the data in a much simpler way. Let's say that, okay, when you complete your whole all the houses in a society, then you come to a conclusion that, okay, so there were like 17 people who were using iPhone, there were 23 people who were using Samsung, and so forth. So this is how you found a raw data and then you actually cleansed it. Now this is the process of cleaning that you call as filtration, cleaning, and other with other names. Now, the third thing that we see is called as representation of the data. Now, in most of the areas, like see, you people would have heard this, that a single picture is worth 1,000 words. Similarly, what are the data that you have found out? You try and actually put it into some pictorial format. Now, this pictorial format, that what are the tools that we use in pictorial format? I'll be writing here representation of data. Okay. In representation of data, we use sometimes pie charts. Now there are different tools, and why and how they are used is based on what type of data we deal with. Okay, so second is the bar graph. The third one is histogram, and the fourth one that we use is called as scatter plots. Each system or each tool has its own best uh, usage and also has its demerit, and based on a particular type of data, it is required to find a meaningful conclusion which can be found from the given data. Now moving further, you have also collected, you have organized, you have cleaned, you have cleansed the data, then you have represented the data. Now the fourth option that comes is analysis of the data. Analysis of the data. Now in the analysis, there are two most important branches that we use. The first one is called as the central tendency. Okay, this is nothing but just a word for mean, mode, and median. So we are all aware with this terminology called mean, mode, and median. Now the second aspect, now the second portion of the analysis is called as dispersion or deviation. And deviation. In this, we use two most important things. The first one is called as variance, and the second one is called as standard deviation. Okay, now there are other ways also in which we use. The first one is first one is quartile deviation and something, but because these methods are very old and the amount of data that we use in statistics is very high. Okay, if I take an example, so I'll be taking like the data which has a frequency, let's say 50, 100, or at max 1000 I will be taking for manual. But when you go in your practical problems, you will be dealing with data that is like very huge, means like millions, lakhs, thousand, whatever, but it's not that small enough to find very quickly using quartile. So therefore we use variance, standard deviation. But if we see from the mathematics point of view, there are four ways. First is range, quartile deviation, variance, and standard deviation. But we use the last two, that is variance and standard deviation. Now moving further, now coming back to the question that I started my discussion with was, what is data? So in this, what the data portion, we'll just see the data aspect of it. So the first portion or the first part that I'm going to discuss with you in statistics is, what is a data? So guys, the data is a simple thing. You can just simply call it, the data is any information collected through observation, survey, or etc. Now in this portion, when I talk about this, the data, there are primarily two type of data that we have, that we'll be dealing a lot in data science. The first one is called as categorical or qualitative data. Categorical and another one is called as the numerical data. Now guys, from the name itself, we can find out what actually these things are, and also we can see that where and how these datas are used. Now if I see, let's say numerical, from the name itself, we see that numerical data is the number one, where the numbers are used. Okay, in this also there are two further types. The first one is called as the discrete data, and another one is called as the continuous data. Now if I give you an example, when you were searching for the people who use different mobile phones, so then you got iPhone as one of the option, let's say 45 people, and after that when you were looking for MI, let's say 22 people, Samsung, then let's say 46 people, and when you were looking, so you even found out OnePlus, right? So this, in this, these things, these observations are singular numbers. So therefore, this is a discrete type of data. But when you people see for, let's say, the marks scored by students in their class, so I'll quote an example. Let's say 0 to 10, 10 to 20, 20 to 30. So this type of data that we have here, in which the observations are in an interval format, are called as, in interval format is called as continuous data. Okay, guys. So this is two type of numerical data that we'll be using throughout our discussion. Now in the categorical one, we have two different type of data. Okay, so before I move on with the two types of categorical data, let me give you an idea. Categorical can be understood of that data where there are characteristics and have some meaning for each options, like the language preference, food menu, movie rating, or most of the options we see while filling a form. I'm sure that most of you would have filled a lot of Google Forms or any other forms during a lockdown period. Now, in this, there are two primary options. The first one is called as the nominal data, and the another one is called as ordinal data. Now, in the nominal data, we have the first option. Let's say, what's your mother tongue? So we may have Hindi, English, okay, Telugu, Tamil, and so forth. So there are a lot of languages that we see here. So when you take this data will have some options from these four only. So you don't have a lot of options, but you have from these particular set of options. Now when it comes to the ordinal data one, or okay, like this is one example. Now you have, let's say, what's your gender? So in gender also you have got female or male. So in these two options only you can have the choice, but not beyond it. Now moving further, in this ordinal is more or less same as nominal, but with a little difference, that the order of options matter or specify. Okay, so in this one, let's say movie rating. So when you talk about a movie rating, obviously uh, you have certain things as, let's say, 5 star, 4 star, 3 star. So again, that is more like in this one, in the nominal one and ordinal one, more or less they are quite same only. But the primary difference comes when you go ahead with your analysis methods. Okay, so this is all that we saw right now. Now moving on further with the second topic of statistics, we see what is our frequency distribution, or how do we basically sort these. Now in the frequency distribution part, first of all, let's understand the meaning of the word called frequency. See, frequency is how many times a particular how many times a particular object repeats. Okay, so a simple example can be, in the above example that I gave you, iPhone was used by 45 people. So this 45 is my frequency. Okay, means how many times or how many users are using it. This is just the simple example for frequency. Now, based on the frequency, we have got 5 different types of frequency distributions, and these distributions are very important when you go ahead with your analysis methods. Okay, so like when you have to find a mean, so for one distribution it would be, the formula would be different. For another distribution the formula would be different. The same goes with variance and standard deviation also. So the 5 types that we have here, so we'll not be using all of them. We'll be using only two to three. Not all of them will be used. So the first we have here is my discrete. The iPhone example that I gave you was discrete FD. This FD is frequency distribution. Now next, going forward, we have got grouped continuous. Grouped. The another example I gave you for the number of students which scored their marks, that was for grouped frequency distribution. Okay. Now going forward, we have got cumulative frequency distribution. It is nothing but just an extension. Only there will be an extra column added. Rest everything remains same. Okay, so these are the three most important that we'll be using here. Rest two are not used so much in data science, or also in the field that we're going to deal with, or the type of numbers or the areas we're going to deal, that are not at all used. Moving further on the third aspect, this was the second part. Now the third aspect is my graphical representations. Yeah. So now guys, we move on to our next section. After we have actually found out the data, we have done all our cleaning and filtration sorting. Now we go ahead with our understanding on representation of the data. Now in the representation part, we basically use four key tools. The first one that is on my extreme left is my pie chart. I'm sure most of us are very much familiar with what actually this structure looks like, or what actually this structure is. So what happens is we have got different heads. So here I have taken a very simple example for you, like let's say that there's a person who's a bachelor, or he has not married. So his or her basic expense for the month would include certain things. So let's say he has food expense. Okay, then he or she would be paying the rent, then miscellaneous. Let's say that you found out this course, you bought this course, so that is your miscellaneous. After that, you would be saving something in your life, and also on food, rent, miscellaneous. And then, though it is education here, but I would be writing, let's say, entertainment. So if there's anybody who likes to go out for movies, parties, that would be included here. Somebody who wants to spend on books, that is also here in this aspect only. Now when we have this whole idea, what happens is, let's say the person, his or her salary is 30,000 for a month. So he spends, let's say, close to 5,000 on food, 8,000 on accommodation or rent, and then further so forth. So what you basically do is, let's say 5,000, this comes out to be 5,518, and then let's say entertainment is 4,000, and this is 8,000. I know most of you hardly find any money to save it, but in most of the cases, this is how the whole expense or the bifurcation of the salary looks like. So this is 5 and 5, 10 in 20. Yeah. So it comes out to be 30K. Now what we basically do is we actually calculate the percentage of 5,000 from 30,000, and then we give that amount of percentage for a particular section in a circle. So this is, and based on how the spent is, let's say that rent and saving are most among these two. So this and this are the highest one. So therefore they will have the biggest chunk. 5,000 food and 5,000 miscellaneous are almost same, so they will look the same. And 4,000, which is an entertainment, seems a bit less, so therefore it will have a lesser chunk. Now moving further, so this pie chart is used for a very simple type of data, that is our discrete data, and not a lot of times it is preferred also because it has certain limitations. The same, that limitation is actually overcome by using the second type, that is called as a bar graph. So the second one that we use is called as the bar graph. Now there are two structures which seemingly look the same. The first one is bar graph and another one is histogram. But there is a very slight difference before we go ahead in the detail. So in the bar graph, we have gaps between the bars, but in histogram, we don't have any gaps between the bars. Now what is basically the use of this is, like suppose here I had only 5 heads. Had I had 15 heads, or let's say 20 heads, then this diagram would have looked very difficult for us to analyze. Okay, so therefore in that case, for discrete data we use bar graphs. Okay, so here we have got two axes. The first one is the x-axis, this is the x-axis, and this is the y-axis. On one side we have our observations, on another, that is the y-axis, we have our frequency. Based on how these bars are, or how much they are, how much their height is, we find out the frequency. Now coming on to the right hand side, that is the histogram part. In a histogram, what we basically look at is, this is for the data I had given you previously, which was your number of students who got this much marks and that much marks. So the data that we have, that we call as a grouped continuous one, this whole idea is, this whole tool is used for that part. So let's say 0 to 10, 10 to 20. Now if you see the first interval, the last, the upper limit and the lower limit, they are both the same, so therefore there is no scope for gaps. This histogram is also used, if you have watched your uh, cricket matches, so then a lot of times this is used. And in this we have another variant, that is our polygon also, histogram. We have got a frequency polygon, so that is also used in most of the cases to compare two type of data. Okay, now moving further, the last and the most important one we use is called as a scatter plots. The scatter plots is very much used, so I have got one example for you of the scatter plot data. So this is my scatter plot. Now basically what scatter plots is, I'll just give you a very brief hint. Scatter plot is also called as scatter graph, scatter chart, scattergram, and further other words. So it is basically a plot or a mathematical diagram using Cartesian coordinates to display values for typically two variable for the set of a data. Okay. Now the last line which I spoke was a bit difficult for you people to understand. See, now the difference between the above data that was, which was represented on a histogram, and the difference for this one, last one, we have in this which we represent on scatter plots. The major difference is that here we are using a data in which we are comparing two items. Like I'll give you an example. Here we are using the countries, their internet speed. Now you see the internet speed, let's say their Wi-Fi speed, and also their per capita GDP. The per capita GDP, that means how much the person is earning. Based on that, we are comparing the Wi-Fi speed, the GDP of that per capita in that country for respective country. So now if you see that I've got two comparative parameters, two parameters on which I want to find out my analysis. Okay, and for the above one, which was on the top right corner, that was histogram, I had one data, or maybe let's say a bar graph, I had got one set of data in which only one comparative parameter was there. Like let's say for country, or the number of mobile phones which are used by people. So the mobile phone was the observation, the brands, and the number was actually the parameter. But here in this case, I have got countries, one parameter is Wi-Fi, another is GDP. Okay, so how do you basically find a relation between the same? Now in this case, if you see, now if you properly see, yeah, so I have certain countries, let's say Indonesia, Thailand, Russia, Romania, Czech Republic, Japan, South Korea. Now, how do we find a right analysis? Okay, so if you see the country that is called as Sweden, Sweden has somewhere, let's say 17 Mbps of internet speed, and the per capita income here is given in dollars. Let's say we find out that is somewhere between, that is 50k. Okay, now if we see, we do not have India, ironically we have USA, right? In USA the average speed is 12 and the per capita income is slightly higher. So which country you feel is where this what do you call it? Inflation is high? Now you see in US the speed is less, still the per capita income is more. That means for getting a better speed you need to pay more, right? But in Sweden, or let's say South Korea, the speed is very high and the per capita income is less. So therefore this is a country where has which has less internet cost. So this is how we find out. But in the scatter plots, this is not only the idea. There is a further extension of topic which we use in this one. Okay, that is called as correlation. Now the correlation one, I have taken two sample photographs. Okay, the one on my right side, that is, you see this thing. Now what's basically a correlation, we'll just look at the basic idea. Basically the scatter diagram is a simplest method to study the correlation between two variables, wherein the value for each pair of a variable is plotted on a graph in the form of a dot. thereby obtaining as many points as the number of observations. Then by looking at the scatter of several points, the degree of correlation is ascertained. Okay. Now in this idea, basically what actually the correlation is, from the name itself we can find out that is a combined relation or a simultaneous relationship between the variables on the x and the y. Now most of you would be wondering that how do we plot on this. Okay, so now if you see earlier in my previous diagrams, that was the bar graph and histogram, on x I had observations and on y I had frequency. But in this diagram, this idea or the designing a bit change. On the x, I have got one parameter, that is the first parameter. On the y, I have got another parameter, that is my second parameter. So now where between that is the common point. Let's say if for one country, for South Korea, the speed is 20.5 and the average the per capita income is basically, or the GDP is, let's say 36 or 38k. Okay, just for an example. So both the point on this coordinate plane where both these coordinates together come, I take one answer. So that is this South Korea. So now you see that there is a line that is going in between. Okay, so some countries are above, some countries are below, right? So now if you see here in this one, UAE, then there are further countries, Ireland, Norway, Singapore, all these countries. Now, to find a meaningful study, we take up the help of a concept called correlation. So, correlation is basically a relationship between the variables or the values on X and values on Y, which is segregated or which is differentiated by one simple method. Now, what we basically do is we draw a line in between, and how a line is drawn, that depends on the study which we'll be going further ahead and we'll be understanding. Now suppose if the correlation we have is of multiple types, so basically this correlation is called, the degree of correlation is denoted by r. And how the degree is, so if I want to give a one line definition to what the degree of correlation is, so we'll look at this point. The degree to which the variables are related to each other depends on the manner in which the points are scattered on the chart. The more the points are scattered over the chart, the lesser is the degree of correlation. See, correlation means what is a communal harmony or what is the bonding between the two variables are. Now the more the scatter they are, let's say that in class everybody is sitting in groups like we had in college. There was one pair which was sitting in one corner, another pair which was sitting in one corner. So then there was very less unity or very less correlation. Hardly anybody knew who was their next partner, who sat before them, who was sat after them. But now in this place, after that idea, in our school we all were very connected, we all used to sit together and have our lunch. Similarly, the data which is very closer, okay, it has a higher correlation degree, and which is very scattered has a very less correlation degree. Even in this there are two categories. One is the positive correlation category and correlation degree, and another is the negative correlation degree. Now in the positive correlation degree, how we see, okay, so I'll just take my first example. That means when the points are very close to a particular line, then the correlation is very high, which is in this case, that is perfect positive correlation. Okay. Now after this, we see that, okay, the points are a bit more scattered. And then we said, okay, they are near, but not very much near. Okay. Then in this case, then in this case, we have highly positive correlation. So that would not be that very high as compared to the previous diagram. Like if you see here, it is 1, here it is 0.8. How are they calculated? It would be discussed later on. We need not go in detail. Right now, we just have to understand how they are used. Next is the positive low correlation, in which the points are very much scattered. Now, from the definition itself, you can find out that hardly there are any points which lie on both the lines. On both the sides which lie on the line. Therefore, the correlation is low. Going forward, now we see the data is in a mess up condition. There is no relation between the same. So therefore, in this case, we say that there is no correlation. Now, after this point, we see that, okay, now all the first three diagrams had a line which was going from lower portion to higher portion. That means The next one, the next point was higher than the previous one. So therefore, this line was going from low to high. In this line, now in this case, we have the next one is lesser than the previous one. Now again, then again, then again, then again, then again. Therefore, it is called as low negative correlation, because see, it is called negative correlation. Why it is low? Because the points are still very scattered. The definition remains the same. After this, we have got highly negative correlation where the points are closer, but the line is from higher to lower. Again, the next point we have is perfect negative correlation. In this case, all the points on the all the points lie on a line, but the line is going from higher to lower. This is the only and only idea behind correlation. So therefore, the scatter diagram method is the simplest device to study the degree of relationship between the variables by plotting the dots for each pair for the values which are given in the data set. Okay, so this was these four things that we have studied. The first one was pie chart, second one was bar graph, third histogram, fourth one is scatter plots. And in the scatter plots, we use a concept that is called as correlation. Now, the three segments of statistics are completely done. The first one was sorting, the next one was arranging, okay, and now the last one is the analysis, in which we have got two most important things, that is our central tendencies and our dispersion. So in this idea of central tendency, the first thing that I'm going to tell you is what basically the central tendency is and how this name is relevant. See, basically central tendency and the next one, that is dispersion, both are measure of certain quantities. Okay, so the measure of central tendency is a single value that describes the way in which a group of data clusters around or circles around, or which is grouped around the central value. Okay, so we have learned about methods of representing data graphically or in a tabular format. Such representation exhibits certain characteristics or salient features for the data. Just to study these salient features, we use a concept that is called as a central tendency. So basically, they give idea about how the data is going on. Okay. So the value that we will be calculating, that is in all mean, mode, median, this value is called as central value for a given data. Okay. The first method that we use in this one, okay, before that, I'll give you a layman language, a layman example. Let's say in a one over, a cricketer scores one run, one, one, then he had a four, a six, and a one. Now, anybody can very easily tell what is the average. So, this average is called as mean in mathematics. So, the average can very easily be found. 1 plus 1 plus 1 plus 1, 4, 4, 4 and 4 is 8, 8 and 6 is 14. So 14 divided by 6, we get our answer, that is 7 by 3. Now moving further, or if I see a better idea about this, the answer comes out to be somewhere as 2.333. Okay. The second one is what is the mode? Mode is the most occurring data out of the same. So in this, I can see the mode is 1 because the cricketer scored 1 as the most runs. Next point is median. Now my median is the middlemost value. Now, when I talk about median, it is that number which actually divides the data in two equal parts. So for this, we organize our data in ascending format. Okay, ascending or descending, but it should be in a particular format. Now after this, we see that 1, 1, 1, 1, 1. So whenever we have any even number of data, the median is found using adding, like we have the total number of observation is 6. So 6 by 2 is 3, and the fourth observation, the third observation and the fourth observation divided by 2. So here we have got 1 and 1. So the third observation is 1, the fourth observation is 1, and their mean is 1. 1 plus 1 by 2 is 1. So basically 1 is the median. That means 1 is the middlemost number of this data. Okay. So you'll be wondering that what was the need to calculate. We can easily see every time that would not be the case. Sometimes it is okay, but not every time this case would be possible. Now what happens is, for the mean, now if I talk about mean in detail and see what are the different methods or what are the different ideas, so we'll see. Now guys, as we are moving deep into our mathematics section, so you'll be wondering whether do we have to practice. It's been a lot of time since we have practiced or we have done our mathematics. Okay, we did 5 years 6 years back in our college or in engineering courses. So I will be telling you something that will give you a lot of relief. The first thing is that you people don't have to manually practice it. When we go further, there'll be certain areas of calculus which will be requiring practice and calculation for you. But don't worry, you don't have to do manually. Everything and everything will be done automatically by computers or the integrated libraries that we have, which are using Python. Okay, so for about all these, it would be told further. Now, the first thing that we see here is the mean. Now, mean is represented using certain symbols of x bar, lambda, or mu based on where this is used. Now, the simplest formula for mean is x bar is equal to total number of observation. Sorry, total observation, sum of observations upon number of observation, right? So this is a very simple one which we have been using since time immemorial. But actually, as the mathematics goes in the greater extent, these formula will not be used. So we will be coming out with different formulas. So the formula for this one would become sigma. Okay, so this symbol is called as sigma, which is also read as summation. So all those who are familiar with Excels, so you would be seeing on your right in your equation, where your equation area is on the top right area, there will be a symbol which looks like this. So in this sigma, we have the answer would come out to be sigma xi fi divided by sigma fi. Then in that extension part, the answer, the formula becomes a plus sigma xi di divided by sigma di multiplied by h. All these formulas were very easily calculated in our excels or in our libraries. Everything is automatically there. We don't have to go in detail, so therefore I'm just touching it up for you people to understand the relevant things. The second thing that we see here is our mode. Okay, so mode is basically the most occurring, I'll write it, most occurring observation. Now, in my above example, I gave you the cricketer scored 1, 1, 1, 1, and 4, 6. So the most occurring number was one. Yes, was 1. So therefore, this was mode. But that was when the case was very simple. But every time this case will not be the same. At times we will be having very big data. So for that data, or in a grouped format data, the formula would something be like this. Mode is equal to L plus f1 minus f0 divided by 2f1 minus f0 minus f2 multiplied by h. Okay, so this is very simple. I'll explain the formula. L is lower limit of modal class. I'm just explaining the formula so that you become well aware with what these terminologies are. Rest you don't have to go in detail, because the extent or the scope of this difficulty will keep on increasing day by day, day by day, day by day. So better is this. So then we have f1. So f1 is frequency of modal class, frequency of preceding class. Next one we have Okay, previous. F2 is frequency of next class, and H is our height or class width. We can understand it like this: class width. Okay, so this was all in mode. Now we see the example of median, or the idea about how median works. Now, median is the middlemost value in the list of numbers. To find the median, the numbers have to be listed in a numerical order from smallest to largest or largest to smallest. Okay. So we can easily find out the answer. Okay. So in this, we have got two cases: when n is even and when n is odd. Now when n is even, we simply just find out the middle. Like say, let's say okay, we have got A, B, C, and D and E. Okay, so first we'll take the case for odd. Now in the odd, we can very easily find the middle one. Okay, which divides the data into equal. Let's say we have got A, B, C, D. So therefore, this is the median. Why? Because it is dividing the data into equal halves. But when it comes to the case for even, we have got 6. So therefore, if I choose the third term, that is C, it is not possible because on one side the data has two terms, another side it has three terms. So the best is that we find out two middle one and then take their mean. Okay, find the mean of the two middle points. So this is when the odd one is there, we simply add 1. N is the number of observations. We add 1 and divide by 2. Now in this case, when the answer is even, we first find n by 2 and the next term. We get two terms, find their mean. Okay, this is all. So this was all which I had to cover in the central tendency portion. Now we move on with the last part, that is my dispersion, the measure of dispersion. This is by far a very important topic in mathematics, and it actually gives the area where the central tendencies fail. Okay. Now, before I move on with my study of deviations, I'll just ask a very simple question. If I say that the average income of India is 30,000 rupees, how many of you will agree? How many of you will agree to this? I'm sure that most of you will say that these figures are not correct. Because on one side we see Ambani, Tata, and Birlas, okay, and on another side we see poor people who hardly have this much during their whole month, okay, and that is actually the most number of people. So even in this case, we have got mode. Most people occur in this, okay, they emerge out from this area. And even if I say the median portion, then the data becomes somewhat incorrect. Okay. So therefore, the central values are inadequate to give us a complete idea of the distribution, as they do not tell us the extent to which the observation vary from the central value. Okay. The variation they do not tell, therefore we have to go in dispersion itself means deviation itself means moving away from the right direction. Okay. So in order to make better interpretation from the data, we observe and find that how the observations are scattered or how much they are bunched around the central value. There can be two or more distributions having the same central values, but still there can be wide disparities in the formation of the distribution. Okay, so I'll give you 2 3 examples to find out that how this disparity or deviation occurs. So first is 1, 5, 9, 13, and 17. The next data that we have is 3, 6, 9, 12, and 15. The next data that we have is 7, 8, 9, 10, and 11. Now, surprisingly, the mean for this is 9. The mean for this is also 9. The mean for this is also 9. Now, if I talk about the mode part, if I talk about the mode part, there is no mode in all. If I talk about the median is also 9. Is also 9 in all the cases. But now if you see that the first observation, there is a difference of 8 units. And here it is difference of 4. In this one, there is a difference of 3 and it is equally spaced. In this, the difference is from the last one, it is 2. But if I see for the central tendencies, 2 out of the 3 values have the same answers. Okay, so therefore my understanding about central tendency is incomplete to find the right and the meaningful discussion about deviations. Okay, so this is where the deviations comes into play. Okay, now all the 3 that we saw here, they can be understood using the deviations, that how the data is basically moving in with respect to each. Okay, so if you follow from the above discussion that the central values are not sufficient to give a complete information about a distribution, variability in the values of the observation of given data give us better information about the data. Okay, variability means how scattered the objects are from each other. Like central values, we have a single number to describe variability of distribution. This single number is called as the dispersion or distribution. Okay, dispersion of distribution. Dispersion of distribution. Now, how do we see about this? So we use two tool or two key methods. Okay. So if you talk about the dispersion, it is the measure of scatteredness. I write a word scatteredness of observations. Means how scattered the observations are around the central value. Around the central value. We do not differ from central value, but we find an extension or we find some more information about how these are around the central value. So as I told you, there are 4 methods to find the answers. The first one is range. Okay. The second one is quartile deviation. The second one is quartile deviation. The third one is mean deviation. The fourth one is mean deviation. And the last one is the standard deviation or variance. Now the first 3 we use, but not as much as we find our answers using standard deviation, because all these, the next method, they overcome certain lacuna or cons which is in the previous method. So we'll directly move on with a standard deviation and variance. So this is by far the most important aspect in our statistics. Okay, so I'll just compare both the items, give their formulas and their understanding. When we have standard deviation, on one side and variance on the other side, the standard deviation, which is denoted by SD, is represented using a symbol called sigma, and the variance is denoted by using a symbol called sigma square. Now from the symbol itself, we can understand there is a very simple relation between the two. That is, the variance is the square of standard deviation. Or I can also say that standard deviation is the root of variance. Okay. Now this gives a clear idea about the two. Okay. So we'll find one and another will follow. The first one that we saw here is standard deviation. So the formula for standard deviation is root over sigma x minus mu square upon n. Now, as I told you in the very initial part of the discussion, that mu is representation of mean. Okay. So therefore, what this is, x, that is observation, and this is my mean, and here is a summation, and this is divided by n, which is the total frequency or total number of observations. So how do we go about it? I'll take a very simple example, and then we'll just see how the calculation for this works. Though I repeat, we do not have to manually do it, but I'll do it just for you to have an idea about the concept. So here we have a simple table which gives us the xi. These xi's are always the observation. Then we have xi minus the mean. Xi minus the mean. You can also write x bar, or you can also write mu. Both are accepted. Then after this, we have the square of the same number. For the ease of calculation, I'm just taking a very simple data and also two different separate columns. But when we do it using machines, the answer comes out instantly. So here we have got 18, we have got 12, we have got 13, we have got 15, and then we have 22. So if I calculate the mean, so we would have very easily found out the mean comes out to be 14. So the mean here is 8 plus 12 plus 13 plus 15 plus 22. The answer is 70 by 5, which is my 14. In this segment, we have got 8 minus 14. So remember that always the observation are taken first. So 8 minus 14, the answer is minus 6. Okay. Then we have got minus 2, minus 1, 1 and 8. Okay. Now we square it up, which is 36, 4, 1, 1 and 64. Okay. Now if I see the sum of it, that means this, which comes out to be 106. So the answer is sigma xi minus x bar square. So this is 106. And as I told, that n is a total number of frequency, which is 5. So the answer is 21.2. And this is what my variance is, because if we observe, there is no root over it. So this is my sigma square. And now when I go in detail, so I'll see that this is my sigma square, and I'm gonna root it up of 21.2, and I get my answer. That is 4.604. Okay. Now most of you would be wondering, sir, if both the things are same, then why are we studying it separately? Okay. Now if you understand the magic of numbers, so let's say our variance comes out to be 5. Okay. And now if I find out the standard, if I found out the standard deviation of 5, the answer would be 2.203 something. It keeps on going. Or let's say if I want to find out the value for root 2, the answer is 1.414. Further it keeps on going to infinite number of places. And when we are dealing with mathematics at a very micro level, then our even a difference in the point would give us a very different answer. So there we use calculus, that I'll teach you later. But right now it is very important that when we are dealing with numbers, we need to be very sensitive towards their deviation. So therefore standard deviation and variance both are used. There are other reasons also, but primarily for you people, when it comes to calculation, this is the best part. Now, this was the whole idea about understanding the analysis part, calculation part. But there is one more important thing in statistics, that is our sample and population, which holds a very simple but important place. Sample and population. Okay. So I'll give you the definition for both of them, and then we'll look at an example that what is a sample and what is a population, and how do we find it. See, population is the entire group of people or thing that we want to study about. Okay, that is the entire. Okay. Let's say I want to make a study about Indians. Okay, so Indian people is my population, and out of that Indian people, I want to make my study, and I want to find about the people who stay, or I want to find out the people who stay in Himalayas. So that is a sample of the whole case. Okay. So the definition for sample is, it is the part of the population that we actually want to collect data or make some observation about. So as I told you, that is Himalayan people. Himalayan people. So this is the part of the population that I want to make my data about or observation about. Okay. So I'll take a very simple example for you people. Let's say a factory overseer collects 50 iPhones. Okay. A factory overseer collects 50 iPhones produced randomly from a batch from those produced that week at the factory. Okay, to test their strength. To test their strength. Now it becomes very easy for me to find out what is the population and what is the sample. Fine. So if I see for the sample and the population, so yes, the population is the population is all the iPhones produced that week, not that which is produced till now, but only in that week, because that is a crucial part in that week. And sample is the batch of, not a batch exactly, but a set of 50 iPhones. 50 iPhones that was collected by the person. So now this is all that we had to discuss in our statistics portion. So giving a very quick recapitulation about what we have discussed. So the very first thing we saw was, how do we basically categorize the data, okay, based on what their different probability, what their different frequency is, or how the data is in a form of frequency distribution. Then we basically first we categorize, then we represent the data, and after the representation of the data, what we do, we analyze the data. And if you remember, or if you find out, whatever you have done till now in statistics is all included in the simple table that I had given you in the initial lecture. Okay, so that is all from my side in your statistics portion. See you then in the next lecture.
Hi everyone, welcome to machine learning. Today we are going to cover introduction part of machine learning. Let us quickly look at the agenda for today's session. Today we are going to cover briefly about what is machine learning, how machine learning algorithms work, what are the real life applications of machine learning, and we will also look at the types of machine learning. Let's dive in. Let us look at the formal definition of what is machine learning. Machine learning is a subset of artificial intelligence which enables systems to learn and make predictions based on the historical data or experiences. All the machine learning models will learn from the historical data, which will act as input data, and based on that, they will make predictions for the new incoming data. For instance, let's say when we are talking about a credit card fraud detection. So here, for the credit card fraud detection model, we are feeding the previous or the historical transactional data and decide whether it's a potential fraud or whether it is a valid transaction. In this particular use case, we observe that we will already have certain fraud transactions which are fed to machine learning model. So based on that, our credit card fraud detection model works. Let us understand how a machine learning model works. The most important or the critical part in any machine learning algorithm is our input data. Input data plays a very important role in our machine learning modeling. The quality and the quantity of the input data matters on how your machine learning algorithm works. Let us not discuss about it now. We will discuss about the input data, the quality and the quantity issues in the coming sessions. For now, let us understand the workflow of machine learning algorithm. Firstly, the input data here is fed to a machine learning algorithm. It is called as training set. So here, the machine learning model is trained using the input data. Here, the machine learning model is trained using the input data. Once the machine learning model is trained, we call it as trained machine learning model. Now, this model has already learned from the previous data. Whenever a new incoming data comes in, this model gives us the output predictions. These predictions are purely based on the input data which the machine learning model has already learned from. So the workflow goes like this. Input data is fed to a machine learning algorithm. We take the trained model, the new input data is fed, and we get the predictions. This is how the simple machine learning algorithms work. Let us look at some of the real life applications of machine learning. First use case is about taxi fare price prediction. Whenever you are booking a cab or a taxi, you see that a fare is displayed in your app. This fare is based on the location where you are booking from, the timing at which you are booking the cab, the distance between the source and the destination, and so many other factors. The other factors include like climate, demand, and so on. So based on this, your taxi fare will be decided. The second such application is spam ham classification. You might have observed whenever you receive an email, it is either classified as spam or it is not classified as spam. The machine learning algorithm or the model which is already trained reads through the content and checks whether it is a potential spam or it is not. This is one more example of machine learning model. One more such application of machine learning is recommender system. You might be an user of Netflix, Amazon Prime, or any other OTT platform. Based on your previous watch history, you will get recommendations for watching new movies. This recommendation is based on a similarity score, which is based on the users who have watched similar kind of movies which you have watched. There are many other applications which you can think of where machine learning is being used. Let us go through the types of machine learning. There are three types of machine learning mainly which we deal with. One is called as supervised machine learning. The other one is unsupervised. The third one is reinforcement learning. Let us look at them one by one. What is supervised learning? Supervised learning is a machine learning technique in which models are being trained with the labeled training data. What do I mean by labeled training data? Here, the data set will contain the input data and the output data, which means we already know the outcome of each observation. In supervised learning, we will have one or more independent variables and the dependent variable, which is called as label, while training. So in this type of machine learning model, we have input data and the output data associated with it, which means we already have the output for a particular input data. Let us, for instance, when we are talking about supervised machine learning, the input data will have an output associated with it, which means in this case, we are sending a dog picture and we are saying that it is a dog. And we are sending a cat picture and we are saying our machine learning model that it is a cat, which means each input variable in a training set will already have a label associated. So this kind of model or this kind of machine learning technique is called as supervised machine learning technique. Now let us look at unsupervised machine learning. Unsupervised machine learning is a technique where the models are trained with the unlabeled training data. What do I mean by unlabeled training data? Here, we will only have input data. We will not have any output data. So in unsupervised machine learning technique, we will only have the independent variables and there would be no output associated. For example, when we are talking about a classification type of problem, let us look at these data. We see that the characteristics of all the 6 pictures over here are same. So seeing them, we can easily tell that this is banana. Similarly, here, when we look at all these 6 pictures over here, we can clearly group them as one more group, and this is called as apple group. Right? So this is a banana group and this is an apple group. Here, we do not explicitly mention any output. So here, whatever the machine learning model learns is from the features of the input. Now, when we have a new data coming in, let's say this one, based on the features or based on the similarity, it could be mostly classified as apple because of its characteristics, right? We will not dig deeper into this. We will talk about the classification problems when we are dealing with it. For now, understand that unsupervised machine learning technique is the one where we only have the input, we will not have the output. Now let us look at the third type of machine learning technique, which is reinforcement learning. Reinforcement learning is a technique where we use reward and punish strategy. What do I mean by that? Whenever we get a desired output, it will be rewarded. And whenever we get the undesired output, it will be punished. Let us take an example and discuss about this. Let's say there is a dog and there is a stick. So the action here is the dog has to catch a stick. If it performs this properly and if it catches the stick, the reward to this dog will be a fish, right? If it doesn't catch this stick properly or if it doesn't perform any action, this dog will not get any reward, right? So here, the reward strategy is if it works as expected, it will be rewarded. If it doesn't work as expected, then it will be punished. So here, similarly, machine learning algorithms also work in a similar fashion. In reinforcement learning, we have a technique of reward and punish, wherein if the desired output is achieved, we will reward, and if not achieved, we will punish. Hi everyone, welcome to machine learning session. Today we are going to discuss about different types of data which we deal with in machine learning data set. Let us look at the different types of data which we are dealing with. One is called as numerical data and the other one is categorical data. What is numerical data? So numerical data is the one which contains numbers as data points. It could be either integers or it could be decimals. Numerical data is also called as quantitative data. Numerical data can be further divided into 2 types. First one is the discrete data and the second one is the continuous data. What is discrete data? Discrete data is any numerical data which has counts and it can take only limited values. For example, if we are talking about number of children in a house, we give exact numbers. So it can take values like 1, 2, 3, and so on. Similarly, when we are counting a number of people in a group, we say a distinct number. For example, let's say 5, 6, 7, and so on. It cannot take numbers like 2.5, 3.2, 5.6, and so on. That's why it is called as discrete data. Now, when we talk about continuous data, any numerical data which can have any value and is not limited to any range of values is called as continuous data. For example, when we are talking about height of person or weight of person and salaries of employees, we are talking about continuous data. For example, a person's weight could be, let's say, 58.6 kgs. It could be 70 kgs, it could be 71.6 kgs. Height of a person could be 5 feet, 5 feet 1 inch, and so on. So it could take values without any restriction. When I say without any restriction, it could be an integer value or decimal value. Let us look at an example. So in this picture, when we are talking about the number of cars parked outside the house, we can easily say that this is 1, 2, 3, 4, and 5. So the answer would be 5. Similarly, when we are talking about the number of households in this particular picture, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the answer would be 11. There can't be any 5.5 cars or there can't be any number like 11.7 number of households. Now let us look at continuous data. Continuous data, as we mentioned, it can take decimal values as well. So when we are talking about weight of a person, let's say this person has 57 kgs and this person could have, let's say, 78.5 kgs. It could be any number between any particular range. Similarly, salaries of employees, it could be in integers or it could be in decimals as well. Now let us look at the categorical form of data. The categorical data are also called as qualitative data. So these are the data which can be divided into groups. Whenever we are talking about categorical data, we come across two types in it. One is called as nominal data. The other one is called as ordinal data. Nominal data is a data which is used to name variables without providing any numerical value. Here, the values are not in any order or any scale. We will talk about this with example. Ordinal data. This is a data type with a set order or scale to it. Each value has a particular meaning in this particular data. Now let us look at the examples of nominal and the ordinal data. When we talk about nominal data, let us say colors. So when we talk about groups, different groups, red is one group, green is another group, and blue is another group. So this is a categorical data which is nominal. Here, from Norway, we can say that red is greater than green or green is greater than blue. Similarly, we have a gender category wherein we have female and male as different groups. We cannot say that male group is greater than female group or female group is greater than male group. So there is no order or scale attached to it. I could write blue first, red second, and green third, or any other format. That's the example of nominal data. When we talk about ordinal data, each group here has a particular meaning. Let's say we are rating a movie where 5-star represents that the movie is awesome, 4-star represents it is excellent, 3-star represents it's good, 2-star is forgettable, and 1-star is awful. Which means each group here has some meaning attached to it. I can say that 5-star movies are better than 4-star, 4-star movies are better rated than 3-star, and so on. Which means I can easily order them in a particular fashion. Another example could be student grades. When I say A plus, A minus, B plus, B, C plus, D, and F, each value here represents a particular meaning. So here I can say that A plus is greater than A minus is greater than B plus is greater than B minus, C plus, and so on. I can write it in a particular order. Another type of data is text data. Here, the data will be extracted text format, which will be mostly used in natural language processing kind of problems. That's about types of data which we deal with. Hope to see you in next session. Hi everyone, welcome to today's session. Today we are going to discuss about raw and processed data. We will understand what is raw data, why do we pre-process it, and how does the processed data looks like. Let us dive in. So raw data is the data which is in its original form and it is extracted from a particular source, which means we have extracted it from the source and we have not done any processing on it, which means it might contain many other features or many other information which may not be needed. For example, if you look at this particular data over here, the data is something which is which has about inflation, annual percentage change in Taiwan, right? So this is from a economic review paper, right? So we have so much information about this particular data over here, but do we need all these data? So for instance, let's say 1897 we have a value over here, right? So 1899 we have value over there here. Maybe this is a information or data of interest, right? But we also have some other details, like what was the period where the survey was done, from which survey it was taken, and so many other information. So whenever you get a data from its original source, it will have information which is having all other information apart from the required data as well. Okay, so this is the raw data. So whenever you come across raw data, understand that the data is in original format, right? Now, why do we need to pre-process this data? So why can't we directly use the raw data which is coming from the source, right? So if you look at this data, so why can't I directly use this for building our machine learning models, right? So what happens? So we have several issues in this particular data. So that issues we have already discussed in the data wrangling part, but let us understand there are several issues which we come across whenever you are dealing with a data set, right? So it could be handling outliers. If you have not seen the video for data wrangling, you can go to the data wrangling section where you will understand different data issues and how do we handle it and so many other informations. But for now, understand that for why do we need to pre-process data, the data in its original format will have a lot of issues. Okay, so we need to handle the outliers. Outliers are the values which are out of range of certain values. Then we will have many missing values. If you can fix those, you can fix those if possible. So for example, if you look at this data, we have 1897 and we don't have any data, right? So if you have some information or if you can fix this, you can fix the issue. You can also see that there might be chances that there are different format issues or numeric issues and so on, because the data which we are dealing with is not coming from a single source. So let's say, for example, we are getting a transactional data, right? So if you consider a bank statement, maybe, right? So it could be a ATM transaction, it could be a debit card transaction, it could be UPI transaction, right? So there are different sources of data from which we get collect the data and then we combine it. So not every transaction will have the same set of fields or same set of values, right? So because of this, when we combine the data, there might be data issues. So we need to remove irrelevant or non-useful data. So if I go back to this, although this information is giving us good knowledge about from where it was taken and those things, but we don't actually need this data for our processing or data analysis, right? So we need to remove all these information. Now The ultimate purpose of pre-processing is to keep only the useful data. So when I say useful data, it could be the data of interest. So let's say if I'm calculating the percentage, or I'm calculating in the coming years what could be the inflation rate, right? So in that case, I don't need all this information. Instead, I just need this information, right? So that's the reason we keep only the useful data. So how does the process data looks like? It looks something like this. So after cleaning, after removal of unnecessary information, irrelevant information, it looks something like this. So we have year column, we have IMF column, and re-insert and rogoff column. So these are the only columns which we need for our data. So this is one such example. So when we look at data which is coming from text data, so whenever we are dealing with the text data, so here you cannot remove everything, right? So because we are dealing with unstructured data, which is the text data, right? So in this case, let's say for example, I have a sentence, the encyclopedia of philosophy or so whatever. So we need to get this information for constructing NLP models or any such models. So in that case, I cannot remove any of this data. Instead, we need to pre-process, or we need to process the data in such a way that a machine can understand. How can we do that? Let's say after processing the data, we kind of assign values for each word. Let's say the value D represents 0. Let's say successor represents 5, right? So we encode the value and we use that instead of the words, right? So here if you see 0:2, right? So it means in a sentence or in a paragraph, we have the word the 2 times. It represents something like that. So let's say we have a value, a word 58, which is repeating 1 time, right? So that's how you convert the raw data, which is unstructured, into a structured, unstructured process data, right? So this is still unstructured because we do not have any columns. We do not have any, specific set of columns which represents the data, right? So that's why it is unstructured data. So that is the process data. So you can use this data and send it to machine learning algorithm, and you can build several models based on that, right? So that's about the raw and the process data. So now let us look at different data formats which we deal with in machine learning model. So there are various formats of data which comes in, and you need to handle them. So most commonly used is the CSV format, which is the comma separated value. And there might be sometimes TSV, which is the tab separated. Instead of comma, we will have a tab space. And then we have JSON, which is JavaScript object notation, and XML, Excel, PDF, and so on. Okay, there are other data formats which are very complicated, RDF and HDFI. Just know about it. No need to dig deeper into it. In among these data formats, Excel and the PDF are the ones which are very difficult to handle, right? So most commonly we will be dealing with CSV, JSON, XML, most probably. Okay, so that's about the data formats. So that's about the raw and process data and the data formats we will be dealing with in machine learning model. So that's it for today's session. So see you in the next session.